what might the coming winter bring? A few things to look at here. We always look at El Nino and La Nina. It's the current status of things through August. And we've basically, where it's red, we have El Nino conditions. Where it's blue, we have La Nina. So we went through a period of a lot of La Ninas from the 50s through the mid-70s. Then it switched to a El Nino dominated period. Now it's been kind of going back and forth. Lately, a little bit more La Nina dominated. Well, the consequences, just what is it right now? So this is the last week, and these are the actual temperatures. These are the departures from average. Blue is a little bit below, so slightly below. And these four areas here, Ninos 1, 2, 3, and 4, are shown in the diagram up here. The history over the last year, with the recent year on the right, recent month on the right. They've been somewhat below average in temperature, but not greatly so. So very mildly La Nina, but not enough to really call it that. Looking back a year ago, this is a worldwide representation of the ocean temperatures, and we had at that time, a year ago, we had some warm water off of Baja, but a big cool area off the coast of west coast of the United States, connected in another cool area up here, and then a warm area through here. A year later, near the same period, the entire area turned out to be above average in temperature. In fact, this is the warmest that the North Pacific has been in the last 30 years from the climate records. So we're not quite sure if this is going to stay this way, if it's going to have an effect on the winter, but there's anomalous warm properties here. By the way, these really warm temperatures up here in the Arctic Ocean are just a consequence of the fact that the ice pack has been diminishing every year, and the sun can shine in and warm it up much more than when there used to be ice there. So we had another low ice extent year this year, which is probably just going to be the norm from now on. And finally, it's updated a little bit through last week. Sorry, this is the latest I could get them, because this site got shut down by the shutdown, and they're still above average. Temperatures are still above average along the west coast of North America. I'll skip this. Excuse me. So these are projections of a bunch of climate models of what the ocean is going to do starting in August, September, October. That's what ASO means. This is forecasts were made in August and projected forward by dynamical models that solve all the equations in the atmosphere, and statistical models that use past history and use statistical approaches. Both those sets of approaches are showing that they don't really expect either La Nina or El Nino to develop. I mean, a very slight tendency favoring El Nino, but this basically boils down to we're not expecting either one of those to occur this year. They're kind of our usual suspects for looking at weather and climate in the southern Great Basin. So here's the official outlooks, the way we're sort of poised to go into winter. For October, the projections were for it to be above average in this part of the United States, and for precipitation to be below average here over the eastern Great Basin. For October, November, December, the next 3 months, above average over most of the western states. And nondescript, EC here means equal chances, or some people say equally clueless. But basically, they're just not able to make a forecast one way or the other. Just don't feel confident in doing it. A little bit on the above side up here in early fall or early winter for the northern tier of the Rockies. Again, they run these out a year, and they're updated every month. So for November, December, January, that 3-month period, temperature above, precipitation probably below in the eastern part of the Great Basin. And for December, January, February, basically the heart of winter, when about 50% of the precipitation in the Sierra typically falls, again above average in temperature and not seeing much of anything in precip. I wanted to point out one other thing. There's another approach that's starting to develop for making our long lead near-term climate forecasts. These are called seasonal interannual. In other words, looking out the next several months or up to a year or so. And these are running numerical models, and there's a group of about 6 of them that are experimenting and cooperating and put their output out in the same format so it can be compared, and so you can directly look at them next to each other. And then there's a technique for combining all of these. Basically, they're like opinions of what the next winter is going to do in something called the National Multi-Model Ensemble. And similarly, there are some international models that also cover the United States that are used to form something called the International Multi-Model Ensemble, which is distinct from the National Multi-Model Ensemble. And I'll show them here. We're missing two of them, the one from NCAR, National Center for Atmospheric Research, and the one from NASA, because of the shutdown. I can't get a hold of the values, or I don't even know if they're generated, if they're running them. But we've got the other four here, which is the Climate Forecast System of the United States, version 2, showing anything in the tan is is below average precipitation. This is for November, December, January, so it's the kind of the early winter. This is the Canadian Meteorological Center, Model 1 and Model 2. They have two versions. They're both showing kind of droughty conditions or dry conditions along the west coast. A little bit wetter maybe further north. And then the Geophysical Fluid Dynamics Laboratory, which is a NOAA facility located in Princeton, New Jersey, showing above average conditions for this period. So we're getting a little bit different mixed picture here. When these are combined together, it looks like the combining process, the below normals win out a little bit over the above normals in terms of believability and so forth. We'll see how this works out. This is all experimental, but it's trying to put this put climate forecasting on a little bit more equal footing to the way weather forecasting is done. It's a giant experiment. And the International Multi-Model Ensemble is showing also dry conditions for this period. So we'll see. This is December, January, February, so we just advanced the whole thing by 1 month and look at it again, and we see here's one that's showing generally positive precip. Here with generally negative precip, although positive in the north. Here's another one that's generally negative for the whole winter. This is the second Canadian model. And another model from the United States showing wetter conditions in Northern California and then across the northern Great Basin and drier down this way. You combine them together, drier in the southern Great Basin, a little bit wetter in the northern Great Basin, and contrast this with the International Ensemble, which is a little bit different the other way. These they run these through a whole battery of comparisons to establish their track record, as if they had been making forecasts all together. This is something called making hindcasts, to sort of establish the credibility of these models. And I haven't shown that there's a mask you can put over them to mask out areas that don't have as much credibility, but when you do that, it really masks out a fair amount of the area. So just interested in seeing what the whole pattern looks like. And finally, here's one for temperature for December, January, February, the same kind of thing. I make these for temp and precip for that 3-month period. Generally on the warm side, which is kind of a typical output anymore of a lot of the climate models. One of them has a big cool spot, actually in the northern tier, but not down in the Great Basin so much. And you combine them all together, both sets of models are looking for a warm winter. All right, what about hydrology? So this is the flow on the Truckee River, and we've got two things shown here. One is the in the tan is the long-term median of the flow, and this is this year, and you can see the big spike from last November or so on the Truckee. This is just above Reno at Farad, but below normal all winter long. Then it's regulated, so it stays the same here, and it drops. They legally drop it on this date over here, so it's kind of following that. On the Carson River, the whole winter, pretty much, there's the long-term median right there. The whole winter this year is well below normal, so we're going into the coming winter with diminished groundwater supplies, because that's what's sort of feeding this, keeping the river won't be low unless the groundwater feeding it is low as well. So this is the Carson at Carson City. Here's the Walker River right near Colville, below Little Walker River. Again, same kind of thing. Been below average stream flow for the past few months or so. And it's going into the winter that way. Here's the poor Humboldt River over at Imlay, which is just above Rye Patch Reservoir. There's the long-term climatology, how much water they get, and here's what they actually got this year. You can walk across the river, such as it is. I think they had like 2% of their volume for the year, just pretty much zero. Pretty pathetic, actually. And then this is up in the northwestern part of the Great Basin on the Pitt River, which comes out of Goose Lake, when Goose Lake is really full, near Canby in California. And generally way below average, a couple of spikes from a few rainstorms here. Finally, one that's out in the center of Nevada. This is not exactly the Columbia River out here, but there are a couple of streams, and they have gauges on them. And this is the South Fork of the Twin River, South Twin River, near Round Mountain, which is right there in Nye County. And way below average. It did come up with some of the September rains here, but this is all relative terms. And if you just look at the numbers here, this is a tenth of a CFS, so it might be more proper to be measuring this in teaspoons per second or something like this, which is more typical of a Nevada river than something in the Pacific Northwest. But for the region, it's decidedly dry. So how the reservoir is looking? Well, the reservoirs are all below average. And their capacity is always, and since the average is, they're never full at this time of year. They're always some smaller percentage of their capacity. So when you rate the numbers, the storage volumes in terms of percent of average, those are always higher than the percent of capacity. Basically, they're showing that Lake Tahoe is about half full, 52%. Of what it could hold on the Tahoe. In Tahoe, the whole Truckee system about 86%, but over on the Carson and the Humboldt, they're running about 7 or 8%, and they're only 2% and 4% of capacity. They're practically empty, the reservoirs. So there's a lot of angst about what this winter is going to bring, whether it's going to be able to bring them back up again. So we've started a new water year. We're 12 days into it. We might as well project out to the end. So based on exit polling from with 1% of the precincts reporting, for the first 12 days of the water year, we got this part of the Colorado River and the San Juan Mountains, 11,000% of average. I don't know if it's going to stay that way for the rest of the year, though. It's a big percent of a small number. So, and for water year precipitation, again, just the first 12 days is just kind of most for fun more than any other thing. This is the start we've had to the water year, and anything in the reds and tans is on the dry side, but that can be made up as the winter moves on. So we'll be following these graphs all winter long, obviously. Just a reminder that we have perpetually run into problems in the Great Basin with the number of dots on a map that describe what's going on there. Anything that anybody can help to improve, any of you who can help to improve where we get this information from and how it's plugged into some ongoing operational summaries, so much the better. We're always hungry for information in the Great Basin, even though we do have some networks that are operating there. A lot of them aren't yet fully coordinated, and or the information isn't combined, so we're looking to do that too. So I'm going to end with a few pictures here, just a small potpourri. Just happened to be out a couple weeks ago looking out our window from my office. This is right out of the office. Our division director showed this to me and says, "This looks kind of strange," and Mark Pitchford is his name. And here's a jet contrail here, and this is heading toward the west, toward San Francisco, and you can see the clouds are blowing off to the left for part of it, and then down a ways they're blowing off to the right. There's a lot of shear going on in the atmosphere here. I don't know what's going on. It looks like a front, and I know a front came through that day. This might have been when the front, where it was at the upper atmosphere at the time. Of course, those of you in Bishop, this is a beautiful thing about living in the 395 corridor. We have some of the best wave clouds in the world. The most beautiful clouds, really, I think almost anywhere in the world, are found from Bishop on up to Susanville. Again, you see some more of those over in the lee of the Rockies near Great Falls and Cut Bank and Calgary. But really beautiful patterns in the sky that you see quite a lot. And all these kind of fantastic shapes. On this day, these were changing like every couple minutes. They're in a big state of flux. Been some well-known experiments to study these clouds in the Bishop area. The mountain wave experiments from the 50s, and more recently in the mid-2000s. And they get a little color when the sun goes down. They get even prettier. This is looking out over the Weather Service building out of our office in Reno. See some interesting shadows being cast by the backlighting. And finally, when the sun gets a little bit lower in the sky, these wave clouds are very dramatic skies. And these look a lot like actually what you're seeing right behind me here is one of Galen Rowell's famous pictures. You see these quite frequently in the lee of the Sierra Nevada. So this is taken out the office window from my office. So I mentioned earlier this is that I was going to show a picture of a Mirage Station. This is the Mather Mirage Station, when I was telling you that had the 2.37 inches of precipitation a couple of weeks ago. This is at 9,100 feet in Great Basin National Park. You can drive practically right up to it. Take a look at it. In the background there is Wheeler Peak. There's a glacier back here. The bristle cones are up here. It's a really nice hike up there. It's 80 feet lower than what you see out your window here at Boundary Peak in the northern end of the White Mountains. This is the second highest peak in Nevada. And it's Great Basin National Park is just a really beautiful place. So I think I'll bring this to a halt there and open it up for questions.